Good morning. Greetings. In this short video, we will review the Bayes theorem. First, I'm going to look at a special case, and then we will discuss a general situation. The special case is probability of F given E is equal to probability of F times probability of E given F divided by this quantity is exactly same as the numerator plus some additional stuff, which is uh, P F prime times P of E given F prime. And that is known as Bayes' theorem, special case. And here, the top, like I said before, this product is exactly same as this product plus some additional stuff. Now, the first comment is, why do you need to apply Bayes' theorem? If you have the probability, this conditional probability here, namely P of E given F, and if you want to compute the other way around, F given E, you got to know all these quantities to be able to compute that. So we apply this Bayes' theorem in this context. You'll be given this along with some additional information, and you have to find P of F given E. That's the main part of Bayes' theorem. And this is not an easy formula to remember. There are primes here. Prime means complements. And there's a way to easily understand this by means of a tree diagram. So let me explain how one could remember this formula by looking at a tree diagram. So for the tree diagram, you have the start, and F could happen, and with the probability of P of F, or the complement of F could happen. The complement is F prime, and the probability of that happening is P of F prime. And when you add these two numbers, you should get 1. When you add PF plus PF prime, that should give you 1. And then followed by E. Given F has happened, what's the probability that E will happen? And this probability is probability of E given F. That's a conditional probability. You write on the branch. Or opposite of E might happen. E complement might happen. This is probability of E prime given F. Likewise, if you follow this branch, following E prime, F prime, E might happen, or the opposite of E might happen. That's E prime. So this probability is the conditional probability, E given F prime, and this is the probability E prime given F prime. F prime appears at the end because F prime has already happened along this branch. And then what's the probability given that F prime has happened, the chances of E prime. So if you write all the things, all these probabilities of each of these, so you have 4 branches of this tree. One branch is this way, second branch is this followed by that, and third is this, and the fourth is that one. Now, we want to know the probability F given E. So look at all the branches that end in E. So there are 2 branches that end in E, this one and this one. So you compute the probability of those things. So what's the probability of this branch here? And if you want to compute the probability, you got to multiply these two. So this is P of F times P of E given F. Notice that that's the top product here. Now if I look at other branch that ends in E and compute the probabilities, that is P of F prime times P of E given F prime. And you see that that's the second term in the bottom. Therefore, the Bayes theorem tells you if you want to compute probability of F given E, you take this in the top, this in the numerator, F followed E, or E followed by F, that's this probability, divided by the sum of these two probabilities. That's how you remember the special case. Okay? One more time. You're given probability of E given F and some other information, and based on that, we want to compute probability of F given E. Simply you construct the tree diagram, and initially there are two possibilities. Either F happens or F does not happen. And then once F happens, what's the probability that E will happen? That's probability of E given F. That's the conditional probability. So anytime you have a branch, these are called branches, there are 4 branches here. If you want to compute the probability of each branch, multiply the probabilities along the path. So this is the path, you multiply those two probabilities, and you're going to get this. And probability of F given E is simply you take that in the top and the sum of these two in the bottom. Okay? Let's see how this works for a 3 by 3 case or a 4 by 4 case. So for a 3 by 3, it's following. Let's say to begin with, starting point, and you have 3 mutually exclusive outcomes, F1, F2, F3. So along this branch, probability of F1, probability of F2, and probability of F3. And then you want E to follow F1, E to follow F2, or E to follow F3. So you have 3 paths here. One, approaching E via F1, getting to E via F2, getting to E via F3. And this means if F1 has happened, what's the probability of E? So this is your conditional probability P of E given F1. And usually that will be given to you. This one is the conditional probability E given F2, and this is probability of E given F3. E given F3. So these will be given to you. Now, let's say I want to compute probability of F1 given E. Notice it's exactly opposite of this. Let's say I want to compute probability of F1 given E. To do that, you take all these branches ending in E and compute the probabilities. As I mentioned before, if you want to compute the probabilities, you got to multiply all these things along these branches. So this is P of F1 times probability of E given F1. This one is probability of F2 times P of E F2. This one is probability of F3, probability of E given F3. So these 3 numbers. Now we want to compute this. Maybe let me write it here. You want to compute this. Probability of exactly opposite of this, F1 given E. So if you want to compute that, F1 given E, this goes to the top, P of F1 times probability of E given F1 goes to the top, and in the bottom you'll have three terms. What are those three terms? You look at all the branches, these are all branches that end in E, you got to add, take the sum. So that means this appears in the bottom and along with some of these other two. So the answer is that divided by P of F1, P of E given F1 plus P of F2 times P of E given F2, and the third one, P of F3 times P of E given F3. That is the probability of F1 given E. If you want to compute F2 given E, this changes F2 to F2 here, and in the bottom exactly the same. If you want to compute P of F3 given E, this will be F3, that will be F3. The denominator is still exactly the same. So this is how you compute, you apply Bayes' theorem. This is Bayes' theorem with three mutually exclusive outcomes to begin with, okay? And you can extend the same thing for 4, 5, 6, no matter however many you have, mutually exclusive, they all add up to 1. You could compute, you could use the Bayes' theorem to write down the formulas from this tree diagram, okay? Thank you.